Yes, my name is Ian Huston. I'm going to talk to you today about a slightly non-technical topic compared to the rest of the talks we're going to have in the PyData session. It's going to be about how data science might fit into the concept of a balanced team. So I'm a data scientist at a company called Pivotal Labs, and I work with clients to help bring data science into their businesses, often large enterprises who maybe don't have the skills they need at the moment, but are trying to build data science teams. But I started working with data back when I was an academic. I did a physics PhD and postdoc. And when I was an academic, one of the main things that I had to contend with was the idea of imposter syndrome. And if any of you have been in academia, you know this is like a big thing that you have to go through. Imposter syndrome is the idea that you really just aren't good enough, and someone's going to find out one day and is going to come and tell you you shouldn't actually be here anymore. And this tweet kind of captures what's going on there. Really, you think that you know a lot less than everyone else, and you're the imposter. You're just playing at this job, and everyone else must be better, must know what they're doing. But in reality, something somewhat different. You've got a certain amount of knowledge, other people have other knowledge, and it kind of overlaps. So that's what I was, when I was in academia, I was kind of faced with that challenge. Like, I'm doing all this data stuff, but I'm, self-taught about programming. I'm, trying to work with these like large data sets, but I don't really know what I'm doing. Surely someone else knows what they're doing. Maybe it's someone in academia, maybe it's outside academia. So that was my first taste of doing kind of data work, was sort of having to encounter this idea. And then I decided I was going to leave academia and I was going to go into industry where, everyone must know how to do things better. And then I got into the strange situation that suddenly I was, being hyped up as this type of data science unicorn. And I was expected to be a data science unicorn, this kind of person who knows everything and they can just bring them into a project and suddenly everything's going to go well. So this means lots of solo work where you are the data scientist and you have to do this and you have to get it right because everyone's depending on you, and there's the full weight of stakeholder expectations sitting on top of you, waiting for you to do this. So it's obviously like a very big leap from this imposter syndrome now to suddenly being sort of held up as, well, you better do this right because you're the unicorn. It's very difficult to make that transition, and it puts people in a very difficult position because all the expectations are on you, and you don't have anyone to talk to about it. You don't have anyone to sound out ideas with, and it's very hard to get the courage to talk about your failures, how you tried something and it didn't work, and you tried something else and it didn't work. It's very difficult to explain that to someone if they just have this idea of you as a unicorn who can look fabulous and wear a mortarboard at the same time. It's kind of amazing. So I was very lucky in that I was able to sort of transition into a role where I started working much more on a sort of team basis, and that's really what I'm going to talk about today. And in particular, I started working with a team at Pivotal, a team of designers, developers, product managers. And we now have an office in Dublin. This is from our launch party last year on Back to the Future Day, so we clearly had to get a branded DeLorean into the picture. But it's been great working as part of a team, and I've been able to learn a lot more about how modern software is developed from the people around me. In particular, I've been really interested in how disciplines like design and product management have been sort of integrated with more traditional software development. So I think this is the sort of transition that data science is going through as well. So what started out as the lone data scientist off doing some analysis is now changing into data scientists being part of the team. How do they interact with that team? How do they build products all together? And that's what the topic of this talk is about. In particular, some of the ideas that have come out of the integration of design and product with software development, including the idea of balanced teams. So balanced teams started out as a series of conversations that happened in 2011 between people who had been working on agile software development teams, but had also been doing design and PM, but in a very, what they thought was a non-optimal way. So you had designers acting as heroes, similar to your data science unicorn. You'd have a hero designer who would take everything about the design on board, do it themselves, often in possibly a different company, a design agency.
Problem is, it's not really time-based because good content is good content. So you'll see articles.
These people who started this conversation didn't really see that as the best way of doing things. So they wanted a way to go faster with less stress. And this isn't a methodology. It's not, you don't buy a book and go to a course. This is really just more of a work environment or a state of mind. And the idea is to try and reduce power struggles in a team and allow for more space for that courage to speak up and speak freely to discard failing solutions. So if you've ever heard of lean startup and the idea of build, measure, learn, you have to learn where you're failing and start again. And giving you the courage to do that is very important. So what is a balanced team? Well, really it kind of, in the sort of canonical way of showing it, it's this combination of development and engineering, UX and design, and sort of business product management. Each has their obligations to the team, and that's kind of an important way to think about that all these people are acting in service to the team. So the team's success is the most important thing, not the individual success. So compared to the days where a designer might be given work and might do that to the best of their ability and give it back, this is now saying that what you're really looking for is to optimize the team's success, not that you, the designer, did the best work you do, rather that the team as a whole is doing the best work it can do. And that has some consequences we'll see later on. In particular, there's shared responsibility, and each role kind of has some obligations and an authority. And there's a lot more about this in this video by Janice Fraser. I recommend, if you want to learn more about balanced team, to go watch it. It talks about balanced team in this context without data science in it, and what I'm going to do today is try and extend that idea to include data science. What does that mean? First, it might be useful to look at what Janice says about a particular role in the team, say a designer. What does a designer do in this balanced team? So the kind of headline is that they're the empathizer-in-chief. So they're the one who understands the customer and translates high-value needs into products. These are their obligations to their team. It's not that they're the expert in these things, but these are the things they bring to the team, and they have an obligation to tell the team when they're doing something that doesn't understand the customer or isn't translating these needs into products. You can imagine, say, for the product manager or the business side, they're translating business needs into product needs, into product. And Janice goes on to talk about how the designers also need to hone their craft, like actually thinking about how do you stay up to date with current techniques, how do you make sure you're doing best practices. That's part of your responsibility to the team. If you're not able to do your design work to the best of your abilities, then you're actually letting your team down. So not thinking about it in terms of personal development, but in terms of team success. And another important obligation is that you have to facilitate balance. We saw the slide with the three parts, kind of development, design, and business side. And if you think about it, in some of those conversations where development and business are tackling some issue, design can come in as a kind of neutral third party to actually facilitate a balanced conversation and keep the customer in mind. And their important authority then is to prioritize customer problems. So at any interaction with the team, that's what their sort of main goal is to do. So in any conversation, we have to, the designer is there to be the voice of the customer. So maybe you can see how this kind of relates in some way to data science. Like we have maybe different obligations, maybe different authorities. And before I go into that, I want to just have a brief snapshot of what it looks like when data isn't part of this idea, when data isn't part of this balanced team. But we can have all the other parts, like the designers, the developers, the PM, the business side, but something is still missing. And I think Monica Rigatti had a great blog post sort of giving an example of that. What is missing when you try and build products without a data person? This blog post about data literacy talks about the Apple Photos product. So Apple has a Photos product. It can recognize faces in a similar way to Google Photos and other products. But when you recognize the faces and you tag them, it shows you 5 faces. And even if you've tagged hundreds of photographs and your nearest and dearest are in probably most of these photographs, if the person you've tagged has a name that's very low in the alphabet, they won't show up in your list of top 5 photographs. because when they were designing the product, they designed it with a purely alphabetical list. So, thinking from a data point of view, well, this is a really, really simple problem to solve. There's no machine learning here. There's no sort of predictive analytics. All we have to do is some simple counting and present the photos in a frequency order so that the people who appear in most photos are at the top of the list. The solution is really simple, but for all the product design and the development that went into this, nobody thought about this simple data-related issue. And Monica Rigati's point is that you really need data thinking to be part of the culture of your team, and it needs to be top of mind so that these product decisions get made. It doesn't need to be an afterthought that you bring in later on. So that's just one example of what happens when data thinking isn't part of your product team. And I've been fortunate enough at Pivotal to work for the last few years on teams that have included data scientists. And we've learned a few things in doing that, and I want to just go through those now, some things that have worked and some things that haven't worked. If you're already working in this kind of agile, lean sort of product way, maybe some of these things you agree with. If there's some other things you want to add to the list, that'd be great to hear as well. If you haven't worked like this before in a sort of balanced product team, then maybe hopefully you can learn from some of the things we did that worked and some of the mistakes we made, I think, along the way. So the first one is to include data exploration and user research, to combine them together. So user research seeks to find the right direction to head in the space of possible products. And often it's very small scale. You might interview 5, 10 people about your product on an ongoing basis. And from that interview, you'd understand, okay, well, people don't seem to like when I put this button here or when I have this caption, or they don't really understand what's going on without some instruction. So that's great. It's really useful to inform your product and how to build it. But I think there's a way that data science and data scientists can help with that process. Certainly as part of a balanced team, I think the data scientist has an obligation to use the available data, whatever data the business has already captured, to inform the lines of questioning for these interviews and research, but also validate the results. So if one of the 5 people you talk to says something surprising about the way they use their product, can you check with all the other customer usage data you have whether this was just a real anomaly that this person does, or whether it's something that's actually ongoing in your customer base? You can also use it to identify gaps where your interviews aren't representative. If you're only interviewing 5 or 10 people, you might be missing quite large chunks of your customer base just purely due to the way that the interviewees were selected. As a data scientist, when I'm building predictive models or sort of machine learning capabilities, I can use user research to help inform questions about how I build this model. Things like how much explainability is needed. Can it be a black box, or must it be something that I can explain to my user? Where's the line between useful and creepy? I was working with a bank, and we were trying to give people more information about their transactions. And one of the things we asked them was, okay, so,
With the system was an event, and each event had either a 1 and a 0 on many.
Champagne and Starbucks. And then we can compare that with how much people like you are paying on coffee each month to see whether you pay more on coffee or not. And that is, I do not want my bank doing that. That is, the sort of visceral reaction people had. It's very interesting to see in user research before you put it into your product, spend a lot of time on it, and suddenly it becomes a big PR issue when you put it out into the wild. Okay, the next one is enabling your product manager to understand data science. If your team has never worked with data scientists or never worked with sort of data in this way, it can be very difficult for them to understand what you can and can't do, what's possible, and how predictive analytics or machine learning can be effectively used. So if you don't educate them about this, it's going to be very hard for them to be able to make product decisions, and that's what a PM does. They take the responsibility of making the decisions for the team. It's going to be very hard for them to do that without understanding how data science can effectively help. So I think if a data scientist in the team has an obligation to be part of these product conversations and story generation from the beginning so that you can proactively suggest where data thinking can be part of it. So not just stepping back, waiting for someone to come to you with some analysis they want done or some place they think that it would be perfect for some data science. You have to be proactive about saying, this is how I think it would be part of the product, and this is how I think we should include it. And that education process extends to the whole team. So, you need your team to be effective in the use of data and to start being able to do this kind of data thinking that Monica Rigatti talks about. You'll need to educate them and involve them, especially if they haven't done this before. But that can be showing them what you're doing, showing them the available data, showing them the types of analysis, even just at a high level, what's possible, what's not possible. Pair programming goes a long way to sharing this knowledge, something I'm going to talk about next. But you can also have a show and tell to describe data discoveries that you've found along the way, and maybe explain the moving parts of the model. So there is some kind of business and product understanding that this thing is not just a black box of machine learning. As I said, pairing is a big thing for us, especially at Pivotal. We do pair programming for development all day, every day. We think it's the best way to get fast feedback cycles and to share knowledge. And for data science, this is no different. So we pair as data scientists as much as possible. We also like to pair with developers and designers to share knowledge between different elements of the team. And you also get a really new perspective on what you're building if you've got a designer sitting beside you saying, is that really what you want to do to show this to the customer? And pairing with developers is particularly useful when you're starting to go down that journey from exploratory work and building a sort of preparatory model to actually putting something in production. They can often stop you from doing something that might send you completely down the wrong direction or put you down a real sort of performance bottleneck very early on because they know what the production system is going to look like. So those are some things that I think did work in these sort of balanced teams that we were trying to work in. Some things that haven't really worked as well. We tried at one point to have a unified development and data science backlog, the idea being that we'd have stories that went from the back end all the way to the front end to the user. So we'd provide user value for the whole process. And the story would be finished when the user could see the value. So we wouldn't have just do some machine learning data science work in the background and then another story to present that to the user. This didn't really work out. It sort of seems like it should, but having a single scale for estimation of those stories proved really difficult across the different disciplines. And it was kind of hard for developers to know when they had to jump in and when it had finished being a data science task and started being a development task. It was kind of hard to do that transition. When the stories are too big, it's really hard to show incremental progress because you're not finishing things on a daily, sort of bi-weekly cadence. It's taking longer and longer, and then it's really hard for the business to see that incremental progress. So what we eventually did was we moved to having separate backlogs for data science and development in a similar way to what we had already been doing for designers. So designers had a separate backlog. But this means extra effort, especially from the PM, to keep the backlogs in sync. So something has to be done first in the data science backlog before it can be done in the development backlog or becomes a blocker. So I think as part of the balanced team, the data scientist actually needs to be in those conversations about the engineering backlog. It's not, you can't just simply take a step back and say, I'm not doing work from that list, so I'm not going to be part of that conversation. And the PM will need to have a really good handle on the interdependencies, or else it's not really going to work. I think that the next one is arriving late to a project. I think there's a tendency, especially amongst some of our clients, to think data scientists should only arrive on a project once maybe an MVP is done and maybe some data is being collected. And even if machine learning is going to be core to the products, like predictive maintenance, there's sometimes a reluctance to bring data scientists in at the product development phase, product creation phase, and only bring them in when it's already decided what the product is going to be. To me, this denies the data scientist the chance to be involved in the early conversations and really talk about the feasibility of different product directions and give advice on what data to start collecting, what early instrumentation you should be doing, and what context can we get from existing data sets. So for me, as part of a balanced team, it's kind of an obligation for a data scientist to contribute from the very beginning, and you have responsibility to stand up and actually ask for that if it's not happening. Next one is being part of multiple teams. As an expensive expert resource, data scientists often get spread widely across different projects to, in some way, maximize their effectiveness. I think the context switching required for this and having multiple simultaneous top priorities makes this really inefficient for the team progress as a whole. And if you have to think about this in terms of the team, maybe your data scientist is individually well utilized because they've always got something to do from their multiple projects. But is the team now waiting because they're in a queue behind other projects to get access to this person. This is a sort of lesson that had been learned by designers, that having designer as part of the team meant that they were accessible. You could just go and ask for design tweak immediately. You didn't have to wait in a queue with the other projects. So because being part of a balanced team puts the team's success first before the individuals, I think this means being, as a data scientist, you have to be available and be focused on a single team or a single product. So this can result in what feels like being an inefficient use of your time if you're not occupied 100%. But the alternative cost to the team is so high that I think it's really important to actually have that focus, even if you don't think, you're not sort of 100% always on the go. I think the last one is kind of just a function of all the hype around data science that we're often seen as the magic bullet, being brought into a project that maybe is not working so well or needs something to spice it up. Let's just put some data science in there, it'll be great. This is a really dangerous situation to get into, I think, and you have to really work to manage the expectations. One of the good things as part of a balanced team is that you have a team of people who are managing those expectations, and you can inform that conversation and then gain by sharing the responsibility of communicating and working with outside stakeholders who have that expectation. So then, to put it all together, what's my kind of take on where data science fits in the balanced team and the kind of style that Janice Fraser had in her talk? Well, if there's a headline, I think it's just that data scientists are the voice of data for the product. So to me, that means providing deep understanding about the available data and identifying potential uses and techniques that could be helpful. I think there's a large ethical component. We need to guard against unjustified, mathematically unjustified uses of the data, but also unethical and inappropriate uses. And I think there's a responsibility or an obligation to begin and continue collection of data where that's not happening, especially in support of future product goals. So, if right now you can't do something because you haven't, enough labeled data or enough historical data, you better start collecting it from now in order to have that in the future to be able to build that idea into your product. Again, data scientists can facilitate balance between other components in the team. And I think our really important authority is that, for every product conversation, we can bring analysis and we can bring data, we can bring sort of insights to that conversation, so that that conversation doesn't need to happen in a vacuum where nobody knows what's going on. So that's, to recap, I think we should make data science part of the idea of a balanced team. This is my silly diagram of what that looks like. But really it means making data a central part of the conversation, providing the insights and possibilities in service to the team. And really what we're talking about is breaking down walls between data scientists and the developers, designers, and product managers who make up the team. So no longer having the lone wolf data science unicorn, but making them an integral part of the team and part of every conversation. So that's it for me. I'll take some questions now, or talk to me on Twitter or after the talk. So thank you very much for listening.
So one of the things I've seen or experienced is this idea of workflow management for data scientists. And you might have covered at the start, but I've seen Kanban, I've seen Agile, and I've seen everything in between, and none of it has ever worked. And I don't know, I'm kind of at the end of my tether as to what would you think, or how, from your experience, how do you manage that workflow? Not so much to get the output, but just in terms of predictable delivery. I think that's the goal.
So that's a really interesting question, the predictable delivery, which is what you're really trying to get. I think you and I know there's different phases of a data science and sort of engagement, whatever that looks like. There's a very exploratory part at the start, which is really hard to estimate. And often, we work in quite a sort of like Kanban, extreme programming style, with our developers, certainly. And I think for that exploratory phase, time boxing works quite well. For the actual more like writing up a model and iterating on the model, we've actually found that using something sort of very similar to a sort of Kanban style with points actually works okay. I talked at the start about how we at one point had a combined development data science backlog, and that didn't work because the stories got too big and the estimation was really hard. When we split it out into just a pure data science backlog, estimation actually got really good, and our velocity was actually quite well maintained. But that was once we knew a lot more about the product domain, the data that was available, and all that sort of stuff. So that exploratory phase really is very unknown. There's a lot of unknowns there. So using time boxing is kind of a technique we do quite a lot of.
Thank you.
Would anyone else like to ask a question? Okay.
Hi, you mentioned about trying to get data scientists concentrating on one team rather than being spread thin over many other teams. How do you kind of prove that value if that's happening, and you know, how do you give quantitative discussion around that to your managers?
Okay, so how do you show them that it's worth having this data scientist who's maybe not 100% utilized?
Yeah, exactly. Yeah.
So if you think back to where kind of where agile programming and kind of lean methodologies started is kind of this idea of workflow management and kind of how pieces of work flow through the system. And one of the places that the teams get stuck is when they're waiting for something else. So if your developers are waiting for a data scientist to finish something, waiting for a data scientist just to be available so they can ask them a question about, did you mean this when you were saying, put this model into production, use these variables. Did you mean this variable or that variable? Or, what size is this going to be? If they have to wait, if that's like, they have this question on Monday, the data scientist is working on another project, okay, they might schedule a meeting for Tuesday afternoon. Something comes up, higher priority on the other project, that's pushed to Wednesday. Now it becomes an email. Then it becomes a phone call. And now suddenly you're like 3 or 4 days, you've had to go back and forth a little while, and all of this could have been taken care of with a 5-minute conversation on Monday morning. You can quantify it with that length of time that your team has been sitting around having to find something else to do, not doing the top priority. So that's really it. Like, how long is your team not doing the top priority? Can you put business value on that in terms of time? You have developers sitting there doing nothing. That's really how I'd quantify it. It seems like a pretty hard-nosed way to do it, but it speaks volumes.